Hello everyone. Today I will present my project on compare thermosensitivity analysis of polymer using DSC and TGA analysis. As you all know, thermal analysis is an aspect of material science that study how material thermal characteristics vary with the temperature. In this project, the main objective is aim to compare the thermal stability of a polymer using two main techniques: differential scanning calorimetry (DSC) and thermogravimetric analysis (TGA). In this project, I use polypropylene. The structure of molecular is really important in identifying the thermal stability. So in this case, polypropylene is composed of repeating unit, where the polymer chains have the methyl group CS3 on every order carbon of the chain backbone. So this structure makes it like more susceptible to degradation through the chain, particularly at the high temperature and in the presence of oxygen. Secondly, crystallinity. The polypropylene able to exist in several crystalline forms, so higher crystallinity typically results in the pattern in better thermal stability because the outer region of the polymer resists thermal motion until the melting point is reached. So let's go to the first technique is DSC. So DSC is the method to identify the variation in heat required to raise the temperature of a sample versus its standards as a function of temperature. So the main objective of this technique is study the thermal property of polymer, including phase transition, melting, crystallization. So let's go to the setup of this technique. First, we will measure a small amount of the sample on the pen right here. We place a sample on the pens, and then the reference right here. Surround the sample and the reference will be the heat sink. So the heat sink used to absorb or dissipate excess heat and help maintain a controlled temperature environment. Heater right here, the orange right here, is provide the control heat both to both reference and the sample. Heat driver connect to the heater and responsible for the driving heat flow to the pan. And then the temperature control is the main thing of this process. Because the system manages the temperature on the entire process, ensure that the heating rate and the temperature range are consistent with the task requirement. The second technique is TGA. So TGA is a technique used to measure the change in mass of a sample as a function of temperature or time. So the main objective of this technique is identify the thermal stability and composition and the temperature through the weight loss of decomposition. For the TGA setup, similar to the DSC, we measure the sample around like 5 to 10 milligram. So the main difference of this setup is about like the carrier gas inlet. So the carrier gas inlets allow the inert or reactive gas to flow into the furnace and preventing the side reaction. So the carrier gas inlet is the main thing different with the DSC. The sample will be placed between like carrier gas inlet and the thermocouple. The balance also the main point of this setup. So it's measure the weight of a sample as the temperature increase. So all of this will be connected to the computer and the control model to run the analysis. The SC results for the polypropylene. So in the lab picture right here, it shows the anatomic peak of polypropylene is melting around like 160 Celsius. On the left side right here is the Smooth curve for the untreated sample around like 110 to 125 Celsius. On the right side right here is the results around like 120 Celsius. The trick sample showed a mini anatomic peak of a several 10 of microwatt. So each heat treatment temperature produced a different crystal structure. Next for the TGA graph for the polar propylene. So based on the picture right here, we're able to see that the curve is relatively flat up to 300 Celsius. So this means that polypropylene is thermally stable in terms of temperature range with no significant weight loss. So after like above the 300 Celsius, it start like decrease sharply. So this point called the thermal degradation point. In generally, it's really hard to compare between DSC and TGA because DSC is primarily used to detect and characterize the phase transitions such as melting, crystallization, and glass transition. But TGA, it measures the mass loss of material as a function of temperature or time. So, in economic benefit, DSC is generally faster and less expensive per analysis, so making it economic benefit for rapid screening and routine testing. First, let's talk about application of DSC in engineering. It's able to use in the pharmacy industry, energy storage, and polymer manufacturing. And teaching the application of TGA in engineering. First is catalyst stability. It will be help us evaluate the thermal stability of catalysts during the various chemical reaction. Second, be material research. So it's help us to investigate the thermal degradation property of material to inform the design of thermal stable material. Lastly, will be environmental engineering. So TGA help us to analyze the thermal degradation of waste material to optimize of the recycling process. Thank you for listening. Thank you for listening to my project.